4:15 in the morning. The grader has been on the haul road since 2. The temperature is -22, and the road surface that was compacted and clean at the end of yesterday's day shift has been worked by the night fleet and needs attention before the morning rotation begins. The grader operator makes one pass along the bench road from the upper cut to the crusher approach, pushing the loose material back to the shoulder, re-establishing the crown that drains water away from the tire track. Another pass coming back. The blade is set to the angle the operator has been running on this road for 2 winters now. By 4:30, the first loaded truck of the morning rotation is already on the grade. The haul route, in an Alberta open pit mine, was not a road in any way that people who drive on public roads would recognize. It was an engineered system graded to specific tolerances, maintained on a continuous schedule, designed around the weight and tire footprint of trucks that weighed 200 tons and more when fully loaded. The grade on the main haul incline ran at 8% or below, calculated against the rim pull curves of the haul trucks, the rolling resistance of the road surface, and the production targets of the mine. A truck that could not make grade was a truck not delivering material, and a truck not delivering material was the processing plant, not receiving feed. The haul route was the mine's circulatory system. Everything else existed to keep it moving. Before we go further, if this kind of history matters to you, consider subscribing to the channel. Every video here is built around the machines and the men who ran them, the haul trucks, the shovels, the open pit, and oil sands operations that fed Canadian industry for decades. If that's worth documenting to you, the subscribe button is how you tell us, and we want to hear from you. Did you work in a Canadian mine, open pit, oil sands, underground, maintenance shop, processing plant? Did a father or grandfather drive haul trucks, operate a shovel, work the blast crew? Did you grow up in a mining town, Fort McMurray, Sudbury, Timmins, Trail, Flin Flon, or somewhere up in the territories? Leave it in the comments. The people who actually work these operations know things that don't appear in any company report. We want to hear from them. Now back to the operation. The haul cycle began at the loading zone. The shovel did not come to the truck. The truck came to the shovel, backing in on a signal from the operator, positioning its body beneath the dipper arc and waiting for 4 passes. Each shovel bucket on a medium-class machine carried approximately 90 tons of oil sands. 4 passes put around 360 tons in the truck body. 2 minutes from first pass to last dump. On a properly run loading cycle, lose the position on the approach, and the dipper could not seat the load correctly. Material went over the side. Wasted cycle. The oil sands itself complicated loading in ways that coal or hard rock did not. In summer, the oil sands clung to the inside of the truck body after the dump, reducing effective payload over successive cycles. Bitumen content in the Athabasca deposit ran from 7 to 13% by weight, and the higher end of that range was the kind of material that adhered to everything it touched. In winter, the problem reversed. Below -20, the oil sands froze into large chunks. The shovel could handle it, but the loading rhythm changed. The operator worked harder against the face. Cycle time extended. A bench that loaded cleanly in October ran differently in January. Pulling a loaded truck up a grade in northern Alberta in February was a different calculation from pulling it in August. In winter, the frozen road surface was firm and predictable, better traction, lower rolling resistance than the summer condition, but cold affected the machines. A cold start before the engine reached operating temperature pulled more fuel and delivered less power. The first loaded climb of a cold shift was managed carefully. Spring was the worst season on the haul roads. The frozen road base began to thaw from the top down. The muskeg beneath certain sections of bench road started to move. A road section that had been stable in January could develop a soft spot by mid-April that could swallow the rear axle of a loaded truck if the driver did not know the road and did not read the surface correctly. Road maintenance was continuous. The graders worked the haul routes on rotation not just in the pre-dawn hours before the day shift, but through the shift, targeting sections where loaded truck traffic had worked the surface into ruts or where drainage had failed. A rutted haul road increased rolling resistance, which increased fuel burn, which slowed the truck's climb, which reduced cycle count, which reduced the tons delivered to the crusher. Every number in that chain mattered. At the top of the haul, the truck reached the crusher. The crusher station received the raw oil sands, a hopper into which the truck backed and tipped its load. In cold weather, frozen oil sands adhered to the truck body. Material that had frozen against the front wall during the haul did not release when the hoist lifted the body. Operators developed techniques for this. A controlled bounce at the end of the hoist cycle, learned on the truck, in the cold, over multiple winters. A body that did not clear fully carried dead weight on the return run and reduced the effective capacity of the next load. The return run was empty, and it was fast. But empty trucks on a steep grade with a frozen surface required attention. The braking characteristics of a 200-ton truck, empty, at speed on a downhill grade, were not the same as a loaded truck. The front axle carried more weight proportionally empty than loaded, and the handling changed accordingly. The cycle from loading zone to crusher and back ran approximately 12 to 15 minutes under normal operating conditions. The processing plant ran on a continuous feed. If the trucks did not run on cycle, the crusher backed up. If the crusher backed up, the conveyor backed up. If the conveyor backed up, the plant absorbed the shortage. The 12 to 15-minute cycle was not an aspiration. It was the operating heartbeat of the mine. The haul truck operator in Alberta's early oil sands mines was not driving in the way that word implies to most people. Dispatch was by radio. A dispatcher in a site office tracked truck positions against a mine schematic, assigned trucks to shovels, called trucks to the crusher when capacity was available, rerouted trucks when a section of haul road was under maintenance, or when the crusher went down. The early dispatch systems used traffic signal lights on the approach roads, green for crusher open, red for crusher down. A red light on the approach meant pulling over and waiting. The trucks sat idling on the bench road, burning fuel, while the crusher crew worked the problem below. The operators who had been on the haul route for years knew the road in the way you know a thing you have driven every day for a decade. They knew which section of bench road ran soft in April. They knew which turn needed to be taken wider when the truck was fully loaded on a frozen surface. That knowledge was not written down anywhere. It existed in the shift crews, in the handover between day and night operators, in the conversations at the fuel station at the start of a shift. Operational knowledge earned over northern winters. It kept the cycle time where it needed to be. The haul route did not stop at the end of a shift. Day shift handed over to night shift at the pit rim. The loaded truck that was climbing when the horns blew did not stop climbing. The route was continuous because the processing plant was continuous. The men who built the haul route understanding did not leave records that documented what they knew. They handed it over, verbally. Between shifts, at the fuel station, in the cab of a truck pulled to the side of the bench road during a crusher hold. That knowledge accumulated over the years. The oil sands industry spent developing the truck and shovel model into the operational system that eventually replaced the drag lines and bucket wheels. The trucks that ran those routes in the 1970s and 1980s are gone. The routes themselves have been extended, widened, redesigned as the pits deepened and the equipment grew larger. But the operating logic load, haul, dump, return has not changed. The cycle is still the mine. If this is the kind of Canadian mining history you want to keep watching, subscribe to the channel. There are more machines, more sites, and more operations still to document. And if you have a connection to what you just watched, a family member who spent their career in a pit or on the patch, a grandfather who ran one of these trucks in northern Canada, someone who was there when this era of mining was still running, tell us in the comments, what did they operate? Which site? What do you remember them saying about the work? The men who ran these machines didn't leave many records behind, but the people who knew them are still here. We want to hear from them.